So for a floating object, okay, floating object which is at static equilibrium. So floating object at static equilibrium means, okay, let's say this is a fluid surface. I have one object here. Okay, and I draw the free body diagram. So mg is always directed downward. Fb is the upward force acting on the object. So at static equilibrium, the buoyant force is always equal to the weight of the object. Because at static equilibrium, summation of F is equal to 0. So Fb plus negative mg is equal to 0. Therefore, Fb is equal to mg. Okay, so for static equilibrium, a floating object, Fb is always equal to mg. And also, according to Archimedes' principle, magnitude of buoyant force is equal to the weight of the fluid displaced. Mass of the fluid displaced multiplied with g. So mass of the fluid displaced means rho of the fluid multiplied with the volume of the fluid displaced multiplied with g. The object which is partially submerged, right? It is floating at static equilibrium. So the volume of the fluid displaced will be equal to the volume of the submerged portion multiplied with g. So that is buoyant force, right? And we just know that for a static equilibrium object, Fb is equal to mg. Therefore, this one is also equal to mg. M is referred to the m of the object. So m of the object. I put as O to represent the object. So now I want to make a comparison relation between the rho of the object to the rho of the fluid. Okay. So mass of the object is rho of the object multiplied with the volume of the object g equal to the rho of the fluid multiplied with the volume of the submerged of the fluid multiplied with g. So g and g can be cancelled off. So eventually you get ratio of the density of the object to the density of the fluid is equal to volume of the submerged portion to the volume of the object. I'd like to add an additional mass of this floating object. So what will happen? So let's say this is the fluid and here is my object. Okay, so we know that mg is here and Fb is here. So Fb is equal to mg. Okay, now I add additional object on top here. So this is the weight of the weight of the floating object. Okay, or buoyant force is equal to the weight of floating object. According to Archimedes' principle, Fb is equal to the weight of the fluid displaced. Now I add an additional weight on the floating object. Now the floating object add additional weight of floating object is equal to the additional weight of the fluid displaced. If you add an object on top of a floating object, so additional weight adding to the floating object is equal to the additional weight of the fluid displaced. If you want to use the mass, so additional mass added to the object is equal to the additional mass of fluid displaced. Okay, added to where? Added to the object, to the floating object. Mass in point 1 is same as mass in point 2 because mass is always constant. So how to get a mass is rho at point 1 multiplied with the volume at point 1 equal to rho at point 2 multiplied with the volume at point 2. So inside the hose or inside the pipe, actually there is a moving fluid. All right, the fluid is flowing. And we assume also the fluid has a uniform density and therefore rho 1 is equal to rho 2. And if V1 is actually same as volume. So how to get a volume at point 1? I know the cross-section area is A1. Okay, so rho 1 is same as rho 2 because the fluid has a uniform density. So volume is A1 multiplied with delta x1, right? X1 is actually the displacement of the fluid at given time. So at the same time interval, the displacement of the fluid at point 2 is x2 or delta x2. So I will get volume V2 is A2 delta x2. Okay, now I'm trying to relate the x with the speed. Point 1, the fluid is moving with the speed of V1. Point 2, the fluid is moving with the speed of V2. So at the same time interval of delta t, this delta x1 is equal to V1 delta t. However, delta x2 is V2 delta t. We are referring to the same time interval. So that's why on the left-hand side is delta t, right-hand side of the delta t. So eventually you can cancel off. And now you will get the continuity equation of A1 V1 is equal to A2 V2, or the product of AV is a constant. If you are referred to 3 points, then it's equal to A3 V3. This equation is called as continuity equation. So the product of AV, we also call it as volume flow rate, which has the unit of meter cube per second. Meter cube per second. Volume flow rate, you can either directly write as AV, or you can use a symbol of rate, R, or you can use dot V. Small letter of V represent the speed of the fluid. This is the speed of the fluid. Capital letter of V, for example, this one is referred to volume. Okay, so there's one dot above here, means rate divided by T. So this one is called it as volume flow rate. We can also have the other one is called as a mass flow rate, M. Mass flow rate means delta M over delta T. Okay, and the unit is mass, so kilogram per second. So this volume flow rate is referred to delta V divided by delta T, volume flow rate, where the unit is meter cube per second. There's a difference between the volume flow rate and mass flow rate. AV is constant, so it implies that A is inversely proportional to V. If you want to have the fluid move with higher speed, the cross-section area must be lower. So next one, move on to the fluid in motion. The assumption that we made for an ideal fluid. So the discussion we discuss here, we always assume that the fluid is an ideal fluid. So what do we mean by ideal fluid? Fluid is non-viscous. Non-viscous means there's no friction between the adjacent layers in the fluid. The fluid is incompressible, means the density of the fluid is constant. The fluid motion is steady. Fluid motion is steady means the velocity, density, and pressure inside the fluid do not change with time. It's always a constant. And the fluid move in a streamline. Move in a streamline means without turbulence or no eddy current. So what is the difference between streamline and turbulence? You can look at the diagram. For laminar flow means a streamline. The fluid in a laminar flow are all in parallel and in a regular manner. But turbulence flow, you can see that is in an irregular manner. There's turbulence flow. So for ideal fluid, the fluid is in streamline or in a laminar flow. You can refer to the other slide also. So for laminar flow, the velocity of the fluid at every point is almost constant and irregular. So this is irregular. This is turbulence flow. Streamline flow can be also called it as laminar flow. So these are the assumptions that we made for ideal fluid. Fluid is non-viscous, incompressible, motion is steady, and it moves in streamline. Okay, so for Bernoulli equation, actually it's an equation. Assume that the fluid is ideal fluid, which is incompressible, non-viscous flow in a steady state and in a laminar flow or non-turbulent flow. P plus half rho V square plus rho GH is a constant. This one is called as Bernoulli equation. P means the pressure. Rho is the density of the fluid. V is the speed of the fluid. Rho is the density. G is gravity. H is height. So it's written here as constant means if you are referring to 2 points, then P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. Okay, for example, if I have a pipe and the fluid is moving in this direction, okay, point 1 is here, point 2 is here. So this is 1 and this is point 2. And we are assuming that the fluid is an ideal fluid, so the density at point 1 is same as density at point 2. So rho is a constant. The speed at point 1 is V1. Speed at point 2 is V2. H1 is actually the height. Okay, if you assume that this is your reference and this one is another point. Here, from here to here is H2 minus H1. So the difference between point 2, the height of point 2 and point 1 is H2 minus H1. And P what is this? P means the pressure. So pressure at point 1 is P1. Pressure at point 2 is P2. It is possible you will have a pipe, something like this. Horizontal pipe. So this one is point 1, here is point 2. So in this case here, while you're applying Bernoulli equation, then I will have P1 plus half rho V1 square is equal to P2 plus half rho V2 squared. Because original Bernoulli equation is actually plus rho GH1 plus rho GH2. But H1 and H2 are equal. So equal means you can cancel off. So that's why you only have P1 plus half rho V1 squared is equal to P2 plus half rho V2 squared. That's why when the speed is higher, V is higher, what happened to the pressure? Pressure is lower. Okay, because of this. P plus half rho V squared must be equal to constant. So if this one is higher, this one must be lower so that you can make this summation a constant. V higher, P will be lower. Bernoulli equation, P plus half rho V 1 square plus rho GH is a constant.